Hello everyone, I'm Sri Harsha. For my final project, I worked on building a lawnmower robot. Let's take a look at the robot's hardware block diagram. I'm using a Raspberry Pi as the controller. I have a 24-volt supply and two voltage regulators. I have various sensors on board. I'll show those in the next slide. I have a motor controller which controls two motors of the robot. Those two motors have their own encoders. I will have a motor to cut the lawn, which will have its own dedicated driver as well. Here is the robot with two wheels. It's a skid steer robot. Here is the Raspberry Pi. Here is the motor controller. Here is the fuse box. Here is the ultrasonic sensor to sense the obstacles ahead. I have the RGB sensor underneath, looking at the ground to sense the color of the grass. Here is the Pocket Lab sensor to collect 9-axis IMU data. I have limited the scope of this project to the navigation part. The idea was to come up with the simplest navigation that works for the application. I have come up with a simple strategy to combine the motor encoder data with the IMU data to give out the robot's current Cartesian coordinates from the starting point as the origin and its azimuth from 0 to 360 degrees. This data gives the ability to cut the grass in straight lines with configured overlap between the lines, and also the ability to cut slant lines pointed at known absolute angle. Given the Cartesian coordinates and the azimuth angle, I also have the ability to do any other cool stuff with the robot sense of direction and known coordinates. I also have additionally an RGB sensor looking down at the grass that gives the intensity of the green color. This data gives the ability to stay within the boundaries of the lawn. With two such sensors, we can even get the ability to track and trim the lawn edges. This is a simple maneuver I performed for demonstration, starting from point A, moving to point B, turning 95 degrees to the left, and then moving on to point C. This is the raw data collected during the maneuver. As you can see, the left turn, which was performed between 15 and 20 seconds, is clearly visible in all the sensors, in accelerometer data, motor encoder data, and then magnetometer data and gyroscope data. This is the high-level insights plotted. As we can see, the estimated path from the sensors is pretty close to the actual path within a few inches, and the azimuth angle is pretty close as well. There is definitely room for improvement with better sensor calibration and sensor fusion. I have not received the motor and blade on time to play with cutting the grass, so I have decided to do something fun with the robot. I drew a heart on the lawn instead. Here is the robot in action. Thank you.